In the modern university, a professor's career survival often hinges on a single number, the Student Evaluation of Teaching score. It is the primary data point for tenure, promotion, and institutional standing. This data is gathered through a multi-criteria questionnaire. Students rate specific facets of a course, like organization, clarity, and fairness, on a 5-point scale. To produce a final result, most institutions use an unweighted arithmetic mean. They simply add the scores and divide by the total number of questions. Mathematically, this calculation assumes that every question on the survey carries exactly the same weight. This logic treats clarity and availability as perfect substitutes for one another. It assumes that a student's perception of a lecturer's personality is worth exactly the same as their perception of the course's structure. However, recent analysis suggests that this equal weight calculation fails to account for how students actually interact with these forms. By treating the data as a simple average, universities may be masking the specific behavioral biases that drive a student's final rating. A 2019 study at an engineering college provided a rare opportunity to test these assumptions by analyzing both the theory of the surveys and the actual voting behavior of the students. The researchers utilized a massive data set. It included detailed surveys from both faculty and students regarding their teaching priorities, alongside a behavioral analysis of over 1,400 completed end-of-semester evaluation forms. The investigation aimed to measure the tension between two groups, the instructors designing the curriculum and the students experiencing it. What they found was a significant gap in what each group defines as high-quality instruction. To understand what a 4.8 out of 5 actually represents, the researchers had to mathematically decouple what people say they value from the raw reality of how they vote. Determining the true importance of these criteria requires a more sophisticated tool than a 1 to 5 ranking. If asked to rate 5 items, people often claim everything is a priority. The researchers instead turned to the Analytic Hierarchy Process, or AHP. AHP functions through pairwise comparisons. It takes 2 criteria and forces the user to choose between them on a sliding scale. You cannot say they are equal. You must decide which is more important in a direct head-to-head match. Once compared, the matrix resolves into a definitive zero-sum hierarchy, assigning a percentage weight to each item to reveal true priorities. The researchers applied this AHP methodology to both the engineering faculty and the students to map their distinct mental models of the classroom. By forcing these choices, AHP exposes true values, setting a baseline to compare how different parties view the exact same teaching process. The raw survey output showed a massive gap between the two groups. When we map these weights onto a radar chart, instructor and student priorities sit at opposite ends. For faculty, the most critical element is organization. They weight course clarity higher than any factor, giving less weight to their own availability. The students prioritize the exact opposite. Their highest weight is placed on lecturer availability and fairness. For them, interpersonal connection is the primary pillar of teaching, while course organization falls to the bottom of their list. The student data was remarkably consistent. Factors like gender or years in school did not statistically change this weighting model. These findings suggest that faculty and students inhabit the same classroom with nearly inverted views of what makes a lecture successful. Theoretical values are only part of the story. We must examine the actual behavioral output, the physical evaluations students submitted at the end of the term. The researchers analyzed 1,436 individual evaluation forms from that semester to see if students were actually distinguishing between the 5 criteria. The data showed a striking lack of variation. In 41.9% of the forms, the variance was exactly 0. A 0 variance form means the student gave the exact same numerical rating to every single question. Whether the question asked about organization or fairness, they marked the same score across the board. This behavior is known as the halo effect. A student's overarching satisfaction with an instructor dictates the entire response. Instead of analyzing each question as a distinct metric, they apply one general sentiment to every checkbox. This means the standard evaluation form isn't collecting 5 pieces of diagnostic data. It's capturing a single impression, repeated 5 times. Combining the halo effect with the fact that students and faculty value different things, the unweighted average begins to look like a poor performance measure. Look what happens to an instructor's final score when we apply different weighting models. Using weights favored by faculty, focusing heavily on organization, the final scores tend to be lower across the board. But when we use the weights derived from the student's own priorities, the final scores tick upward. In almost every rating tier, the student-weighted average is higher than the standard unweighted mean. This increase happens because students tend to give slightly higher raw scores to interpersonal metrics, the very things they value most. When the math is adjusted to reflect those values, the final average rises. This shows that equal weighting is not a neutral mathematical choice. It actively misrepresents how the primary stakeholders perceive value in the classroom. These findings suggest it's time to redesign the physical teaching evaluation. Because of the halo effect, most of these questions are mathematically redundant. Asking students for granular details on 5 or 10 different topics yields very little unique information. It's an inefficient use of institutional resources that rarely produces new diagnostic insight. To be more effective, evaluation should feature fewer criteria. Administrators must acknowledge that these forms measure a general student sentiment, rather than providing a precise diagnosis of teaching methods. For faculty who are judged by these metrics, the strategic takeaway is clear. Many instructors spend hours over-organizing their course materials in an attempt to raise their scores. But since students weight organization lower than other traits, this effort often fails to move the needle. A more efficient path is to focus on the interpersonal metrics students actually prioritize: availability, fairness, and approachability. Navigating the modern university means understanding the evaluation for what it is: a specific data architecture with predictable biases. Mastering it requires aligning your effort